All right, so we have this normal distribution, some sort of set of data. It has a mean of 48 and a standard deviation of 5. I don't know, maybe these are heights of kindergartners. The mean height of 48 with a standard deviation of 5. That's a really big standard deviation. Maybe that's not it. Whatever. So, what we did when we talked about the empirical rule is we drew our curve like this. We said, okay, our mean is 48. So one standard deviation above, we're going to add 5 to that. So 53. If we add 5 again, that's 2 standard deviations. Add 5 again. Okay. And then we subtract 5. And we subtract 5. And we subtract 5. So that's what we did. And then we wanted to know, okay, where does a person with a z-score, not a z-score, an x value of 45, like where are they in this distribution? Well, 45 is going to be, I don't know, right in here. So it looks like, if we're talking about heights or whatever, this person is a little bit below average, okay? Not a full standard deviation, but a little bit below average, okay? So that's what we did before with the empirical rule. But what we want to do now is we want to convert this to the standard normal distribution. So instead of having a mean of 48, we're just going to have a mean of 0, and we're going to see where's 1 standard deviation above, 2, 3, and 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. So we need to convert this 45 to a z-score. So remember, z is x minus mu over sigma. So our x value is 45, our mu is 48, and sigma is 5. So we get negative 3 over 5, which as a decimal is negative 0.6. So this is telling us, the negative is telling us we're below the mean, and 0.6 means we're about 0.6. So this value falls about right here. 0.6 of a standard deviation below the mean. Okay, so notice these are telling us the same thing. It's just by converting to the standard normal distribution, we don't have to remake this every time. We can just stick with the 0, 1, 2, 3, and negative 1, negative 2, negative 3. All right, heights of adult men are normally distributed with a mean of 69.1 inches and standard deviation of 2.9 inches. We're going to find the z-score of a height of 62 inches and indicate where that would be. So what we just did up there. So first, I'm going to draw this. Okay, so remember we're converting to the standard normal. So our mean is 0. We can be 1 standard deviation above, 2 or 3. 1 below, 2 below, 3 below. Now remember, you could be further than this. It's just unlikely. Doesn't happen a whole lot. So to calculate a z-score, we do x minus mu over sigma. In this case, x is 62. That's how tall our person is. Our mean is 69.1. And standard deviation is 2.9. All right, I can find a calculator here. 62 minus 69.1 is going to be negative 7.1. I'm going to go ahead and divide that while I'm at my calculator. So I get negative 2.45. Usually with z-scores, we go 2 decimal places on. So this person is negative 2, which means it is below the mean. So almost 2.5 below the mean. So this is where that person falls as far as height. So they're a little bit on the short side, a little below average. So that is lesson 6.1. It is drawing our standard normal distribution, finding z-scores, and locating those z-scores on it. This is really foundational for the rest of Chapter 6 and really the rest of what we do in statistics. So I want to make sure you have a good understanding of this. So practice through this in 6.1 and we'll expand on it on the next lesson.